So let's continue with our playlist. But before that, hey everyone, welcome back to the channel. I hope you guys are doing extreme.
If I didn't miss you, baby, I hope that you know you were appreciated. Around my house, I still got up all of our pictures, baby. Cause I still love you, that's how I feel at my core. Flew different states to come see you in between tour. I gave you everything I had and even more. Just understand it's not like me to give my heart away, ay. Now you taking distance and it's hard to take, ay. I've tried everything to get your thoughts to change, ay. I tried not to listen when they always say, ay, this was temporary and you walk away. It'll always be easy to blame you, but it's my fault for thinking I could fix you, fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact that I can't. Fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact I can't fix you now. You said to me, baby, you was all in. I think we just probably should've stayed friends. I think that we probably could've saved tears. Just understand it's not like me to give my heart away, ay. Now you taking distance and it's hard to take, ay. I've tried everything to get your thoughts to change, ay. I tried not to listen when they always say, ay, this was temporary and you walk away. It'll always be easy to blame you, but it's my fault for thinking I could fix you, fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact that I can't. Fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact I can't fix you now.
I need that. I need that.
Little white bitch on Depop, she a little teapot, 2 left feet, them Reebok. Shawty did freelance, now she a free thot. Shoulda never let the bitch alone with my seat. My not a bitch get pit popping in my Reeboks. Talking about a detox, busy like a big box. All grown up, bitch looking like Salid, not that booty. I need that, I need that, I need that. Little white bitch on Depop, she a little teapot, 2 left feet, them Reebok. Shawty did freelance, now she a free thot. Shoulda never let the bitch alone with my seat. My not a bitch get pit popping in my Reeboks. Talking about a detox, busy like a big box. All grown up, bitch looking like Salid, not that booty. I need that, I need that, I need that. Little white bitch on Depop, she a little teapot, 2 left feet, them Reebok. Shawty did freelance, now she a free thot. Shoulda never let the bitch alone with my seat. My not a bitch get pit popping in my Reeboks. Talking about a detox, busy like a big box. All grown up, bitch looking like Salid, not that booty.
Could've been 30, could've been a G. Should've never snitched. Why you take it to police? Started looking at you funny when you walking down the street. Looking at you like food, trying to see where they can eat. Me, I'm like Wallow and Gilly with the game. You don't really wanna act silly, behave. When I were on stage and a million gets made. I need that, I need that, I need that grease. I feel sorry for Skepta, they copy these flow, but they said that it's a new flow. Imitation don't flatter me, but it's cool though. Should've ever left the guy alone in my studio. Put them in the coffin, get them on a tombstone. Yeah, I got a half of the price of a Q-Do. Living like a boss man, nothing like Hugo. I need that, I need that, I need that good price. When the plug turned pagan, tweaking, took an inflation. Peace is needed, getting impatient. Blood, everybody getting complacent. Leg, work, step on the pavement. Victory lap, I'm back in the station. I'm really a psycho, Patrick Bateman. If you see her with me, she's taken.
Little white bitch on Depop, she a little teapot, 2 left feet, them Reebok. Shawty did freelance, now she a free thot. Shoulda never let the bitch alone with my seat. My not a bitch get pit popping in my Reeboks. Talking about a detox, busy like a big box. All grown up, bitch looking like Salid, not. I need that, I need that, I need that, I need that.
Money in my motherfucking briefcase, C-pay. Every time I kill a beat, I probate, okay. Circulated paper, let it rotate all day. Need it in my hands, no all state. Not rush more when I'm looking for the big face. So much failure when I gotta get a replay. Gotta hustle hard with the flow, so I tell the DJ. Don't stop the argument or you get targeted. Pistol unpocketed, very anonymous. Niggas be talking shit off of the populace. Finna start popping in front of your audience. When you wanna go, you gotta keep that fire. Legend from the M-I-A-M-I. Gardeners where all of the hardest reside.
well. So the problem that we will be solving today is rotating a given linked list. So you'll be given a linked list and you'll be given the value k. Your task is to rotate the linked list by k times. So over here k is 2. I'll have to rotate it 2 times. So if I rotate it 1 time, this is how the linked list will look like. So what happens is from the back, one element comes out, comes to the front, and this gets shifted rightwards by 1 place each. So this is how it will look like after 1 rotation. So on this, if I do 1 more rotation, the last element will come at the front and the front elements will get shifted by 1 place ahead. So can I say after 2 rotations, this is how the updated linked list will look like. So your task is to return the updated head after doing k rotations. So you might have a question, hey, what is the range of k? So the range of k can be anything. Like in this particular example, the length is 5. K can be 1, k can be 5, k can be 10, k can be 100, k can be 1000 as well. K can be anything. But as of now, we will try solving this problem for smaller values of k. Once we have done that, we will see how can we solve it for larger values. So k is given as 2. Let's observe what is happening. The last 2 nodes are at the front, but this is linked list. We don't care about that. If we can see the link changes, I think our job will be done. So this is the tail node. Its next is pointing to null. After two rotations, the tail node, its next is pointing to the initial head. This is the initial head. So the first job is to recognize the tail node. We can easily do it by doing a simple traversal. We start from here and we reach here. So we can easily recognize the tail node. Once you have done that, its next is pointing to null. Instead of it, I'll make sure this is pointing to the head. This is pointing to the head. So we can do that. Let's try to do it. Instead of this, I'll make sure that this is pointing to the head. Done. What after this? Let's visualize. We have a 3, it's pointing to null. We have a 3 here, which is pointing to 4. Correct? So I'll have to change this link. K is given as 2. So if you see the last 2 nodes are eliminated, if you eliminate the last 2 nodes from your vision, this is the node, right? Right before the last 2 nodes. So can I say, if the total length is 5, if I eliminate 2, I need the third node. First, second, third. I need the third node. So I have to get into that third node. Again, by traversal, I can reach the third node. Imagine you are standing at this node, which is the third node. What is your job? Your job is to make sure this is pointing to null. This is pointing to null. But wait. You need to return the updated head. So what you can do is, once you're standing over here, you can straight away say, hey, this will be my updated head. You can change the head from here and you can take it there. Once you have done that, you can remove it. Yes, you can remove it. And you can make sure temporaries next is pointing to null. Done. What will happen? So your head is here. This is like 4, 5, then goes to 1, then goes to 2, then goes to 3, which is exactly this particular linked list. Done and dusted. Now you might be thinking, hey, what if the value of k is large? What if the value of k is more than the length or it's equivalent to length? So let's go back a couple of steps. So we know how to solve this particular problem for smaller values of k. Now we need to think about larger values of k. What if the value of k is given as 5, which is basically the length of the linked list? What will happen? Can I say, if the length is given as 5, and if I try rotating, I'll come back to the original configuration. You can try rotating it for 5 times. You will see that you come back to the original configuration. So we see that if k is equivalent to the length, We don't need to do anything. We return the head. What if k is 10? It's basically you rotate once for 5, you'll come back to the original. Again, you rotate for 5 times, you'll again come back to the original. So you eventually come back to the original, even if you rotate it for 10 times. If you rotate it for 15, you rotate for 5, another 5, another 5. Each, like every time you come back to the original configuration. So if it is a multiple of the length, very important. If it is a multiple of the length, it comes back to the original configuration. So you don't need to do anything. You just return the given head. So that's something that you have to do. If your k is modulated with length, you don't need to do anything. You straight away return the head. That's an edge case that you have to handle. What if k is given as 13? Can I say I can write it as 5 plus 5 plus 3, which technically means coming back to its original, and you just need to do 3 rotations. You don't need to do 13 rotations. You just need to do 3 rotations. And 3 is a smaller number for which we have solved. We have solved this particular problem for smaller numbers. Done and dusted. Got it? So we have solved this problem for smaller values of k and for larger values of k as well. So what is the next thing that we need to do? We need to make sure that the algorithm works. What do we need? We need the length so that we can determine this, and also we can reduce the value of k in case it's a larger value. Also, we need the tail because we need to do the changes in the length. So let's take tail to be at tail because we need to do the changes in the length. So let's take tail to be at the head initially. Let's take the length to be 1. Let's try moving. Tail will go here and length will be updated to length 2. Let's move. Tail and length will go to the next. The length will be updated to 3. Tail will go to the next and length will be updated to 4. Tail will go to the next and length will be updated to 5. Understood? So tail is standing at the tail and the first traversal is completed. So you have the length. Depending on the length, you can perform your edge case, right? If k is given as, let's say 14. If k is given as 14, doesn't matter. What you need to do is 14 modulo 5, you'll get it, right? So this is your length. Perfect. You have the tail. What is the next thing that you'll do? The next thing that you'll do is, you'll make sure that the tail's next is pointing to the head. Very simple. Tail's next to head. So one step is done. That is taking the tail and making sure its next is pointing to the initial head. Because after rotation, that is how it will look like. What is the next job? The new last node, or rather the new tail node, it should be pointing to null. So let's first locate the new tail node. That's very simple. You have to leave out the last 2 elements. So if the length is 5 minus k, so you have to find the third element. You have to find the third element. You can easily do by traversal. Like you can keep a temporary here and you can keep a counter equal to 1. Let's try moving. Temporary will move here. Counter will increase. Let's again try moving. Temporary will move here. Counter will increase. And this is where you reach. And once you have reached here, you know that temporary like is standing at that new last node. Once this is done, you can update your head to this one. And that's very simple. Temporaries next will be your new head. Once this is done, make sure temporaries next is pointing to null. Done and dusted. Quite simple. So I'll be writing down the pseudocode. It won't be language specific. In case you want the C++, Java, Python or JavaScript codes, the link will be in the description. What do we need initially? We need the length. Let's assign the length to be 1 and we need the tail. So let's assign the tail to be head, correct? Let's try to traverse while tails next is not null because I need to make sure I reach the tail, not beyond it. Let's assign the length to be 1 and we need the tail. So let's assign the tail to be head, correct? Let's try to traverse while tails next is not null because I need to make sure I reach the tail, not beyond it. So till it's not null, I can do a length plus plus, and at the same time I can say tail equal to tails next. Perfect. After this, what will happen is I'll have the length and I'll also have the tail. In case k is directly divisible by length, we don't do anything, we will return the head. If it is not the case, then we do the link changes. How will we do the link changes? But before that, please make sure that k is modulated by length. In case k is a larger value. What is the first thing that we will do? Tails next. Perfect. After this, what will happen is I'll have the length and I'll also have the tail. In case k is directly divisible by length, we don't do anything, we will return the head. If it is not the case, then we do the link changes. How will we do the link changes? But before that, please make sure that k is modulated by length. In case k is a larger value. What is the first thing that we will do? Changes. How will we do the link changes? But before that, please make sure that k is modulated by length. In case k is a larger value. What is the first thing that we will do? We'll make sure that the tails next is pointing to head. Done. So I can say that the first step of the operation is done. The first step is done. Now what is your next step? To locate the new last node, which will basically be your new tail. Can I probably write a function that finds me the nth node? I'll pass on the head. I need to find length minus k. 5 minus 2. The third node. Basically be your is done. Now what is your next step? To locate the new last node, which will basically be your new tail. Can I probably write a function that finds me the nth node? I'll pass on the head. I need to find length minus k. 5 minus 2. The third node. I'll write a function like a generic function that will find me it. Once I've done this, what is the job? My head will be updated. If you remember, the third node. I'll write a function new tail. Can I probably write a function that finds me the nth node? I'll pass on the head. I need to find length minus k. 5 minus 2. The third node. I'll write a function like a generic function that will find me it. Once I've done this, what is the job? My head will be updated. If you remember, the head will be updated because 4 will be my new head. Please update your head. Your head will be new last node. Next. Perfect. What after this? This new last node. This is your new last node, right? It has to point to null. That is why it's the last node, right? Done. And once this is done, you can return the head of the linked list. Perfect. Quite simple. So this is the entire pseudocode. Now it's time to go back into the code editor. And you can see that I've written down the edge case. What if the linked list is empty or if there are 0 rotations? In that case, return the given head itself. And I've written down the generic nth node function where you take the count equal to 1 and if it's equivalent to your k. Return that node, otherwise you move ahead, increase the count and you move ahead. Quite simple. And this stays the same. What I'll do is I'll hit the submit button and this will be accepted. Let's analyze the time complexity. I can say this is definitely a big O of n for sure. Am I using anything else? Probably here. What if at the worst case k is 1? In that case, to find the nth node, you'll have to traverse the entire linked list near about. So I can say big O of n over here, and this nth node at the worst by 1 and 2. So slow will be here. So let's continue with our playlist. But before that, hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is detecting a loop in a given linked list. So what is the problem stating? It is stating that you'll be given the head of a linked list. Yes, you'll be given the head of a linked list and you'll have to return me true if there is a loop in that given linked list. So what is the definition of a loop when it comes to linked list? Now the definition is if there exists a minimum of one node where you start and you reach back, then we can say that the linked list has a loop. Let me explain you. If I start at 4 and I move ahead, I'll be reaching back to 4. I'll be reaching back to 4. So I'm sure that there is a minimum form of one node. Well, have to return me true if the. So let's continue the playlist. But before that, hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is detecting a loop in a given linked list. So what is the problem stating? It is stating that you'll be given the head of a linked list. Yes, you'll be given the head of a linked list, and you'll have to return me true if there is a loop in that given linked list. So what is the definition of a loop when it comes to linked list? And the definition is if there exists a minimum of one node where you start and you reach back, then we can say that the linked list has a loop. Let me explain you. If I start at 4 and I move ahead, I'll be reaching back to 4. I'll be reaching back to 4. So I'm sure that there is a minimum of one node where I can start and reach back. And if there does exist a minimum of one node, I can say that there is a loop, and in that case, I'll be returning true. Got it? Now over here there are multiple nodes, 3, 4, 5, 6, 7, 8, 9. If you start from any of them, you will reach back. But if you start from one, you will never reach back one. So that is why I'm saying a minimum of one node is required. What if this problem comes up in an interview? We will be starting off with the extreme range solution. And what will be that? What are we looking for? We are saying that in case there is a minimum of one node where you start and you reach back, that means it is visited more than once. It is visited more than once. I'll have to remember somehow that I've seen it previously, because when I'm traversing, I need to remember that I had seen 5 previously, and that is when I reach back 5, I'll know, hey, I did see this node previously, and that is what will tell me that, hey, there is one node minimum which has been seen twice, and if it has been seen twice, it means that you're on a loop. So which data structure to use to remember these things? Yeah, you're correct. We'll be using the concept of hashing. So what we will do is, again, we'll not tamper head. We will take temporary and we will take a map data structure. So let's take a map data structure. And what we will do is this map data structure will be of the type node. Node will be the key and integer or boolean. So basically the node will be the key, and integer 1 or boolean 1 or boolean 2 will tell me if I saw that, or integer 0 will tell me that I haven't seen it. So what we do is we start with the temporary, which is the node 1. So we keep the node 1 and we say I've seen it. Perfect. Let's move the temporary to the next. Goes to 2. I'll store 2 and say I've seen it. Goes to 3. I'll store 3 and then move ahead. Goes to 4. I'll store 4 and move ahead. Goes to 5. Remember, you store the entire node, not the values. Not the values, because it might happen. The values might repeat in the node. So do not store the values. Store the entire node, entire object in itself. Okay. So 5 stored. Let's move to 6. 6 stored. Let's move to 7. 7 stored. Let's move to 8. Before storing it, just introduce a small step to check if this 3 that you're currently at, is it in the map? And you can see that there's a node with 3. There's a node, exact same node. I'm not considering the values. I'll be comparing the object. Is it the same memory location? It says yes, it is the same memory location. It is pointing to the same memory location. If it is, I can say that I've encountered a loop and I will stop. So this is what we can do. Like, we can simply use hashing. So if I have to write down the code, can I say I require the map data structure, which will be storing the node in Java, node star in C++, int, and a map. Again, I'll be writing the pseudo code. You can find out the C++, Java, Python, JavaScript codes in the description below. Put in C++, you can straight away say temporary equal to 1. In Java, you can write mpp.put. The moment it would have ended at null, the while will be done and operations. So depending on if your map takes log, the time complexity and the space complexity, this is where the interviewer will not be happy with the extra space that you're using and he'll ask you to optimize it. So the optimal approach will be using the tortoise and the hare algorithm. In case you are not aware of this, please go back and watch out the lecture finding the middle of the linked list, because that is where I've discussed this algorithm, the slow and the fast pointer algorithm, which is basically the tortoise and the hare algorithm. So in this particular algorithm, we take couple of pointers, slow and the fast pointer. Slow will be moving by 1 step, the fast pointer will be moving by 2 step, and they will be moving simultaneously together. So what we do is, we're given the head of the linked list, right? So we will take 2 pointers, slow and the fast pointer, and we will try to move them simultaneously, one by one, the other by 2. So let's start slow and fast. Let's move them together. Slow, as we said, by 1, fast, as we said, by 2. That's the first step. 1, 2, done. Let's do the next step. Again, slow and fast will move by 1 and 1. So slow will reach here and the fast will reach here. So this is where they reach. I'll be raising this so that it has more clarity. In the next step, again they'll be moving 2 steps. So the fast pointer will reach here and the slow pointer will reach here. So this is how it moves step by step. In the next step, again they'll be moving 2 steps. The fast pointer will reach here and the slow pointer will reach here. So this is how it will look like. Perfect. In the next step, again move them by 1 and 2. So slow will be here and the fast pointer will be somewhere here, because 2 steps, it doesn't go like it will not go in this direction, it has to go in this direction. So this is what it will look like after the step. It's one more step, slow and fast. Slow will go, sorry, my bad. Slow will be over here and fast pointer will move over here. Perfect. This is how it will look like. And the next step, slow will move over here and fast pointer will move over here. And this is when they stop. And this is when they stop. And if they're meeting, I repeat, if they're meeting, you will be like, yes, there is a loop. So after the step, you can see that the slow and the fast pointer are standing at the same node. If it happens to stand at the same node at any junction, you can definitely say that there was a loop. There was a loop. That is why they're standing at the same node. And you're returning true. As of now, just remember this. You might be thinking, why? What if they cross over? What if? How are we so sure that they will be colliding at a single node? What if they cross over? I'll be telling you the entire intuition. Do not worry about that. Please stay with me till the end. So before I move on to the intuition, what if we have a linear linked list with odd number of nodes? Over here, n is odd. What if we have a linear linked list with even number of nodes? In that case, what will be our stop condition? Because in this case, we'll be just rotating around. There is no stop condition. The stop condition is whenever we meet slow, like whenever the slow and the fast pointer meets, that is the stop condition. What about linear linked list without loops? What is the stop condition? We did it while doing the middle of the linked list. I'll be doing it again. Slow and fast stands at the head, simultaneously slow and fast. Remember, if at any moment you stand at the last node, you stop there and there. Which means if you're fast, got next is not. Let's check out the case for the other one. So I'll do the cases. So please make sure that the fast pointer never reaches null as well, because if it reaches, that means it is a linear data structure, linear linked list, and you need to stop. Got it? So what you do is you initially have slow equal to head. You also have the fast equal to head. And let's do this. What are we waiting for? Slow equal to slow. Next. Fast equal to fast. Next. Next. You know, if anyone slow is standing very fast, it means there is a loop to run to. If loop returns false, it means it's a linear data structure, and if it means that, I will be returning false because it will never have a loop. Otherwise, it will never reach the last node or the null. So it'll be returning false. So this is how the code will look like for the optimal approach. And you might be thinking, we have understood the code, we have understood the algorithm. But what is the intuition? Because how are we so sure that they will be colliding at a certain point? They might cross over, right? And they might never collide. So how are we proving that they will collide? Let's understand that. So what did we do? we took a slow pointer and we placed it at the head. We took a fast pointer and we placed it at the head. And after that, simultaneously, we moved slow by 1 and the fast by 2. Correct? So let's move the slow by 1 and the fast pointer by 2 steps. That was the first step, right? What was the next? We took the slow and we moved it by 1 and we took the fast pointer and moved it by 2 steps. So let's move it. We stop here and I will be proving you why they will collide and why they will never overlap. They will collide if there is a loop. Slow is standing here, the fast pointer is standing here. Can I say the distance between fast and slow, not slow and fast, fast and slow, how much is that? That's 1, 2, 3, 4, 5. Can I say that the distance between them is d? Let's assume the distance d, and in this example it is 5. In this example it is 5, and overall we can assume it is d. D can be any number, it can be prime, it can be odd, it can be even, it can be any number. Now tell me one thing, after this process what will happen? Let's erase this. After this process what will happen? The fast pointer will again move by 1 step, sorry 2 step, and the slow pointer will move by 1 step. Can I see this? I can, and I'll erase it. Now if I ask you, what is the distance between the fast and the slow? Not slow and fast, fast and the slow. You'll be like, the distance is 1, 2, 3, 4. D is 4. What was the reduction in distance? 1. The reduction in distance was 1. Okay, why did that happen? Because the slow is moving by 1 and the fast is moving by 2. And you had a distance between the fast and the slow as d. That was the distance. So the fast is moving towards slow by 2. And the slow is moving away by 1. What is the net reduction? What is the net reduction that they will have? The net reduction will boil down to d minus 1. Will boil down to d minus 1 because fast is moving 2. Fast is moving 2 towards slow is moving faster by 1. Overall reduction will be 1. Fast is moving 1. So next 3. Yes, next 2. I can move this next 1. Everything point is 0. Everything point is 0. So one thing I have proved is no matter how far is fast from slow, the d can be any number or even anything. It can be anything. But d will reduce to d minus 1 to d minus 2 and it will end up reducing to 0 because we are reducing it by 1. It's 1. And you know, d is always divisible by 1. So it is bound to reduce to 0. It is bound to reduce to 0. That is why we move it by 2 steps and move it by 1 step. So that the difference is 1. We can move it by 3 as well. But in that case, the difference will not be 1. And you might not reach 0. Because the difference in distance is 1. Because the difference in distance is 1. It's bound to reach 0. It's bound to reach 0. And this is the intuition. So that was about the proof that why will they collide, and I hope you've understood the intuition behind moving the slow by 1 and the fast by 2, because we want to keep the difference as 1 so that they collide. Got it? So I hope you've understood the intuition and the proof, and you can watch out most of the YouTube videos. What they do is, this moves by 1 step, this moves by 2 step, and whenever they collide, we return true. That's it. They will never tell you why are we moving it by 1, why are we moving it by 2, why. They will never tell you that, trust me. And this is the reason I'm telling you, please do watch my videos, because I'll not be just they do is this moves by 1 step, this moves by 2 step, and whenever they collide, we return 2. That's it. They will never tell you why are we moving it by 1, why are we moving it by 2, why. They will never tell you that. Trust me. And this is the reason I'm telling you, please do watch my videos, because I'll not be just cramming you up algorithms. I'll be telling you about the thought process.
Eyes on the prize, agonize when you're all alone. You know you lie, but you still call my phone. Try and try again, but it's no hope. I cannot lie, you were just a call. We could be heroes. Hunt me down, catch me, gear me down, slow speed, turn me out, backseat. You know, flip it 360, master lock, kiss me, burning bridge city. Hell no, take a breath, I feel empty. Trespass on me, spin it, get dizzy. I'm so forgotten, so missing. Screaming, I'm sinking, never stop winning. Eyes on the prize, agonize when we're all alone. Eyes on the prize, you know you lie, but you still call my phone. You lie, but you still call my phone. Try and try again, but it's no hope. I cannot lie, you were just a call. I cannot lie, you were just a call. You were just a call. You were just a call. Calm down. Breathe, calm down. Breathe, calm down. Do you trust me? Do you trust me?
Baby, don't be my crush when the shit get gory. Got that radioactive touch, I'm for purgatory. She heard the story, I've been
wearing a demon, barely been eating, scrolling all night, that's why I can't get the grieving.
Baby, don't be my crush when the shit get gory. Got that radioactive touch, I'm from purgatory. She heard the story, I've been
wearing a demon, barely been eating, scrolling all night. Break it all down, like what does it mean to me? I got in this position so damn easily. Think I got good intentions, I got decency, but am I really a good person when I need to be?
I need to be. He put me on a pedestal and like 9 tweets. I'm getting this tightness in my chest, it made me grind my teeth. So I'ma just take another edible and go 5G. Old friends that hate me now, I'm never gonna find my feet. Always pitting myself up. top, I can't be rewarded. Go re-record it, I've been
wearing a demon, barely been eating, scrolling all night, that's why I can't get the grieving.
Baby, don't be my crush when the sick get gory. Got that radioactive touch, I'm from purgatory. So you heard the story, I've been
wearing a demon, barely been eating, scrolling all night.
Oh, don't be my crush when the sick get gory. Got that radioactive touch, I'm from purgatory. I know I'm never gonna need your love, I can feel supported. Got this feeling in my gut, dread it every morning. Heat distortion.
Eyes on the phone, crazy to get my head out of shit I regret. Eyes on the phone, breathing in overtime, it's nothing but net. Eyes on the phone, face on an open mind, I get budget to feed. Eyes on the phone, the farming on retention for a buck like all you people. They're using us like a resource. That's when I start to think, well, fuck, there ain't no recourse. I profit all keystrokes, playing into it, filling my plate. Unstoppable heat source, burning off any minute I take it. And when I die, I hope I'm buried in a forest. That is, if any of it's left, the shit is torrid. For now, I'm using up my gift to write a chorus.
Always putting myself above you to feel important. No, I'm never gonna take that top, I can't be rewarded. Go re-record it, I've been
wearing a demon, barely been eating, scrolling all night.
Baby, don't be my crush when the sick get gory. Got that radioactive touch, I'm from purgatory. She heard the story, I've been
wearing a demon, barely been eating, scrolling all night. That's why I can't break it all down. Like, what does it mean? There ain't ways to a new biome to make a case for the new iPhone. The water's laced and they know I know. Wearing a demon, can't get the grieving,
Hollywood.
can't get the breathing.
Once again, I'm the one bath.
Gotta repeat it.
Hollow.
Too busy dreaming. That's why I can't. That's why
Help.
a hypochondriac. I think you blood pressure spikes. I'll have a heart attack. The things I do.
And I just mind my business, killer shit, subby witness. Been a big fish, so you better listen. Never mention, but I'll blow back. And I never take it easy, no relax. Then I bang, get me jet lag. If you mean shit, we won't check tags. If I fuck up, I'd have been back. I mean, जानो ना तू चाहती क्या हो, मैं बेवजह हूँ ढूंढता भी क्या. तेरे बिन सुकून ना तो तू होना मुझसे दूर ना कभी. तुझे ही हूँ ढूंढता पर तेरा भी तो कसूर ना. तेरी कमी को डरा और अब ये भी है सभी को पता. ये बता दे कि तू चाहती क्या है. देखे ना तेरे सिवा को यहाँ पे करता नहीं तुझसे जब तक खुद से बातें. तू जानती मेरे सारे राज है, फिर सुनती बातें क्यों आते जाते. और सोचे कि तू मुझे न जाने, मेरी जान ही ले ले तू अनजान है. आती नींद मुझे तरसता दे, करने आता बात तो कहती रास्ता दे. कहती कहता झूठ तू मुझे से फरेक, और दिखे सब तुझे से हम ताते. मैं जानू ना कि क्या खता करी है कहाँ कभी. ओ नो नो नो, ये बता के करूँ क्या मेरी ये सजा करे खत्म है जो वो. जानू ना तू चाहती क्या हो, मैं बेवजह हूँ ढूंढता भी क्या. तेरे बिन सुकून ना तो तू होना मुझसे दूर ना कभी. तुझे ही हूँ ढूंढता पर तेरा भी तो कसूर ना. तेरी कमी को डरा और अब ये भी है सभी को पता.
थाम मेरा हाथ चल साथ cloud9 सिर्फ तू ही तू चाहे कोई और नहीं बात ऑनलाइन क्यों नहीं होती ऑफलाइन बे I need you तेरी जैसी और नहीं करा try काफी मैंने करा try करी बाय बातें तेरी करी बाय never lied I swear to God I've never lied DMs try शायद कदम तेरा free trial करा try काफी मैंने करा try करी बाय बातें तेरी करी बाय never lied I swear to God I've never lied DMs try शायद कदम तेरा free trial मेरा हाथ चल साथ cloud9 सिर्फ तू ही तू चाहे कोई और नहीं बात ऑनलाइन क्यों नहीं होती ऑफलाइन बे I need you तेरी जैसी और नहीं
Who is I to think that I could fix you, baby? Who would I be if I didn't miss you, baby? I hope that you know you were appreciated. Around my house, I still got up all of our pictures, baby. Cause I still love you, that's how I feel at my core. Flew different states to come see you in between tour. I gave you everything I had and even more. Just understand it's not like me to give my heart away, ayy. Now you taking distance and it's hard to take, ayy. I tried everything to get your thoughts to change, ayy. I tried not to listen when they always say, ayy. This was temporary and you walk away. It'll always be easy to blame you, but it's my fault for thinking I could fix you, fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact that I can't. Fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact I can't fix you now. You said to me, baby, you was all in. I think we just probably should've stayed friends. I think that we probably could've saved tears. Saved it. Just understand it's not like me to give my heart away, ayy. Now you taking distance and it's hard to take, ayy. I've tried everything to get your thoughts to change, ayy. I tried not to listen when they always say, ayy. This was temporary and you walk away. It'll always be easy to blame you, but it's my fault for thinking I could fix you, fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact that I can't. Fix you, fix you, fix you, fix you, fix you, fix you. Wish I could miss you, miss you, miss you, I miss you. It's really hard to accept the fact I can't fix you now.
हेलो हेलो दोस्तों, कैसे हैं आप लोग? यार ये कहाँ से ले रहा है? आई एम नॉट ओके। लैपटॉप माइक इट इज। 2 क्वेश्चन लगाया है भाई यार, एक घंटे 1.5 घंटा करीब बैठ के सिर्फ 2 क्वेश्चन लगे. I'm gonna clutch tonight. I'm gonna clutch tonight. Whoops! OBS just crashed! Uh, where is it? Where is it? Huh? Where is it? Detect a cycle in linked list. This is what a cycle is, I guess, yeah? हाँ, साइकिल ही बोलते हैं ना इसको. हाँ, ठीक है, चलो ये हो गया. All right. Check if a linked list is a palindrome or not. Okay, this is a good question. मैंने मीडियम लेवल का किया था अभी, एंड ये वाला है हाँ, ये भी मीडियम है. ठीक है, आई थिंक आई कैन डू दिस. चेक इफ अरे मेरे को इसका लिखना है, नोट्स नहीं लिखना है इसको. वेयर इज इट? Yeah, here is it. Here it is. Oh no. Okay. Okay, I'm gonna put it on mute and I'm gonna just study again. It was a nice break though.
So that you can solve new problems as well. I'll be teaching you real problems.
दोस्तों आई विल बी बैक। मेरे को थोड़ा बाहर जाना है, मेरे को वॉक करने जाना था। तो अभी टाइम हो रहा है 12, 12:30 हो रहा है अभी। और आई हैव टू गो एंड आई गेस आई विल बी बैक इन 15 मिनट्स। 15 मिनट्स। ओके। दो क्वेश्चन नहीं हुए अभी तक, बट मैं खींचूंगा भाई आज। आज करना ही पड़ेगा। ओके, तो आई विल बी बैक। ओके, ब्रेक टाइम। हेलो गाइस, आई एम बैक एंड मैंने मैगी बना भी ली और मैंने मैगी खा भी ली एंड इट्स टाइम टू resume my DSA. Yeah, come on. Okay, getting myself and starting with the DSA again. Sucks, but I have to do that. I have no choice here. I have to.
Solving over here. So what will be the time complexity? It will be somewhere around big of n. I cannot pinpoint that this is the time complexity because depending on different test cases, it might vary. You might just find it at the earliest step, you might find it at the end, you might find it at the middle, right? What about the space complexity? We're not using any external space. We're using just the slow pointer and the fast pointer. So that is about the time complexity and the space complexity. So let's quickly get back Back into the code editor. As you can see, we need to return a boolean.
Hey, everybody, this is Larry. This is day 8 of the Lico March Daily Challenge. Hey, everybody, this is Larry. This is day 8 of the Lico March Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. Okay, so I mean, this one, just true and false version. Okay, so I mean, I have a video on the other one where it's probably the second version of this where you have to find the beginning of it as well. There are a couple of ways you can do this. The way that I do is just call Freud's, I forget what it's called, maybe cycle detection. Maybe that's what I would Google for, or tortoise and hare algo, or a fast and slow pointer is what I call it. But basically, the idea is that if there's a loop, and you move 2 pointers, one at a faster speed than the other, you eventually they'll catch up, and that's the idea. I don't know. I mean, this one is such a trivia thing and something that's been gone over so many times that I don't think I'm going to spend that much time on it today. Just because I don't know, everyone has. I don't know. And if this is new to you, then definitely check out my other videos I have done before on different variation on this, and some of them I spent a lot of time on even. So, but yeah, but now you have a fast point as you go to head, slow as you go to head, fast is not none, and oops, and slow is not oops, none. So technically, I guess fast only we but fast is you go fast dot next. If fast dot next is, or if fast is not none, fast is you go fast dot next. Slow is you go to slow dot next. If fast is you go to slow, we turn true. Otherwise, we return false when one of these, mostly fast, will become yeah. Hopefully this is right. Otherwise, I just said a lot of stuff to be wrong. Okay, so I did get this wrong. Why is this wrong? Oh, wait. Head. Okay, so. Oh, okay. So if fast is none, then that means that we got out the loop, so we return true. But that's not what the issue is, right? Why did I return false here? Well, why did I return true? I'm very sloppy today, I guess. But let's see. What does position 1 mean? Okay, I don't know what this stuff means. But okay. Wow. This is what happens when you're silly. But okay, let's see. I guess they could both be none as y. So okay, let's put it here instead. How am I returning true? I think that wasn't needed, but I mean, this is only returning true if this is. Oh, well, I mean, this part is. Yeah. Hey everybody, this is Larry. This is day fourth of the League Code Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, and maybe for Labor Day we're getting a little bit less labor because we're getting a Yeezy problem here. Linked list cycle on 141. Alright, let's see what's up. Which one is this? Oh, it's just the true force version. Okay. I mean, yeah, I don't have much to say about this one. I think we've done this one. I have probably like 3 videos on this at least. So I'm just gonna go right into it. The idea is what's it called? The tortoise and the hare or something? The rabbit and the turtle or whatever. Basically you have 2 pointers, you have one goes 2 steps and the other one go 1 step, and then basically if there's a loop, eventually the faster hare or rabbit will basically catch back up, like loop around, basically lapping them. It's almost basically like me in gym class getting lapped and getting caught up or something like this, right? So yeah, that's basically the idea, and this is the link this problem, which I don't really find super interesting anyway, but that's besides the point. I suppose no one asked me if they find it interesting. Maybe you do. I don't know. But yeah, so while fast is not none, fast is go fast not next. Fast is go. So we go 2 steps and 1 step for the slower one, right? Yeah. Can't help making mistakes, right? And then if fast is equal to slow, then we return true. Otherwise, eventually we return false when we get out the loop. That means that fast is equal to none. Keeping in mind that this is a reference equal, but that's fine because for this particular problem, that's where we are. Of course, maybe I'm just wrong. There's no cycle, and I return true anyway. Oh, because this. Huh? I actually didn't know this. I didn't know that. I didn't know that none is equal to none is equal to true. That's not always true in every language. And even though I've done this in Python, yeah, I mean, I guess in this case, then we go just if fast is none, then we return true, right? You could also do it after here, right? And then otherwise, but I didn't know that. Wait, is that the reason? I return true, expected. Oh, if this is none, we return false. Obviously, I'm just being dumb. I am very dumb. Can you? I feel like I only do these problems when I'm like
So let's continue to our playlist. But before that, hey everyone, come back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is check if a given linked list is palindrome or not. So what is the problem stating? You'll be given the head of the linked list and you have to check if it is palindrome or not. Now what is the definition of palindrome? Anything written in reverse should be the same. So basically, if you're given a string, something like mom, and if you try to write it in the reverse order, M O M, it's the same mom, right? So any number, any string, any given thing, if you try to write it in the reverse order, it is the same. It is the same. Then you call it as a palindrome. Now, what is the definition in terms of linked list? You cannot just pick up the data. You cannot pick up the data and write it in a reverse order. What you will do is, you'll take the last, place it, 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 and then compare. If they are equal, they are, right? So if such is the scenario, you will be returning true. Otherwise, you'll be returning false. So the question is stating, given a linked list, so basically you'll be given the head of the linked list, you'll have to return true if it is palindrome, you'll have to return false if it is not palindrome. So this is the case for odd length of linked list. What is for the even length? It's the same thing. You take the last, take the second last, the third last, fourth last, fifth last, and the first one. So if you again compare, they are similar. So this is also a palindromic linked list. Let's look at another example. You're given 1, 2, 3, 2, 3. Let's try to write it. Take the last, and if you write it, you will see that they are not matching. They're not matching, you're returning false, stating that it is not a palindrome. However, this question comes up in an interview. What is the extreme length solution that you can think of? Like what I can think of is, I need to preserve them. So what I'll do is, I'll take data structure. Let's take a stack data structure, and we'll understand why as we move forward. And initially, let's keep a temporary pointing to the head of the linked list. What is the data temporary? 1. Take it and put it into your stack data structure. Remember, stack is the last in, first out data structure. Remember this. Let's move to the next. What is the value? 2. Put it into the stack. Let's move to the next. What's the value? 3. Put it into the stack. Let's move to the next. What's the value? 2. Put it into the stack. Let's move to the next. What is the value? 1. Let's move to the temp. And you reach null, and you will stop. The moment you stop, the stack will have all the values. Look at the stack, it has all the values. Let's do step 2 of the algorithm. Step 2 is again taking the temporary, placing it at the head. This time it will be the comparison step. What you do is, whatever is the value, and you compare it with the top element of the stack. Stack is in last in, first out. So the last entered element was 1. So if you do the top, you'll get the last element. Okay, so you get the top element as 1, and that is matching with temporary. So you say it is matching, and let's move. In case it is not matching, and you take it out of the stack. In case it is not matching, you say it is false, stating that it is not palindrome. Let's take out the next. 2 is matching, let's move. Let's take out the next. 3 is matching, let's move. 2 is matching, let's move. 1 is matching, let's move. And you reach null. The moment you reach null, all of your stack is empty. You will be like, okay, all the comparisons were true, thereby meaning it is a palindrome. Very simple. So if I have to write down the code, okay, it's going to be super simple. You'll basically take a stack data structure, you'll take a temporary which is pointing to the head of the linked list, and the step 1 will be traversing the entire linked list, which is temporary is not equal to null. And you'll say stack, can you please push or add depending on the language that you're using, temporary of data. Done. And then you get the temporary equal to temporary dot next. So that's the step 1. This is the step 1 where you store everything in your stack data structure. Let's try out the step 2. What is the step 2? You need to compare, right? So again we will take temporary, and this time we'll make it point to head. Never ever alt the head, because you never know. While you write code, you might require it in the future. So let's go while again with the traversal till we reach the end, temp not equal to null. This time we say if temporary data or value, whatever it is storing, value or data, is not equal to stack.tops data. In that case, we will straight away say, hey, this is not palindrome, and we will return false. In case they're matching, what we will do is the temporary can equal to the next. And if your language, like whatever language you're using, if the top doesn't delete the top element, you use the stack.pop, so that will pop it out. Once this is done, all the checks are done, and if temporary ends up reaching null, it means it was palindrome. So you'll be returning true. What is the time complexity? Can I say the step 1's time complexity is big O of 1 because I'm going to the entire list, putting everything into the stack. So what is the time complexity for step 2? Can I say big O of n? Very simple, because again we're traversing. So what is the overall time complexity? Big O of 2n. What is the overall space complexity? Big O of n, because we're storing every element in the stack. This is where the interviewer will not be happy with the extra space that you're using, and you'll ask you to optimize it. So let's quickly try to optimize. So we cannot use an external data structure, which brings us to the place that whatever we need to do, we need to do it in the given linked list. We need to do some link changes. Whatever algorithm is, it should be restricted to the given linked list. Let's try to think. What are we trying to achieve? Compare 1 and 1. Compare 2 and 2. Compare 3 and 3. If the first half is compared with the second half, and all the elements are matching, it's a linked list. If one of the elements in that is not matching, it is not a linked list. That's what I'm trying to achieve. What is the problem that we're facing? Like we can simply keep one point at the head, we can keep one point at the tail, match head with the tail, matching, move the head, one place ahead, move the tail point to one place back, and then match it again. But the question arises, it's a singly linked list, it's not a doubly linked list. How do you move back? How do you move back? That's where the problem starts. So overall thing is, I know I need to compare the first half and the second half. That is in case of a even length linked list. We'll talk about the odd length afterwards, but in case of even length, we need to match the first half and the second half. But the problem that is arising is, I cannot go back because the links are in the forward direction. It's not a doubly linked list. Okay, how do we do it? So first thing that comes to my mind is, okay, what if somehow I can change the links and make it like make 1's next pointer pointing to 2, 2's next pointer pointing to 3. In that case, I can stand here and do the traversal. Okay, changing links, reversing the links comes to my brain. Fine, but for that I need to recognize which one is the second half. I need to recognize which one is the second half. So step 1 is recognizing the second half, right? Let's try to do it. How can you find the middle of the linked list? Yes, the tortoise and the hare algorithm. In case you haven't seen my video on finding the middle of the linked list, go back and watch it. The link will be in the description. Please go back and watch it. Over there we did use something as slow and fast pointers. In case of even length of linked list, we have two middle 1 and middle 2, right? What we will try to do is try to somehow reach middle 1. In our middle of the linked list problem, we try to reach here, right? Let's try to do it. I'll take slow and the fast pointer. First step, slow and fast moves simultaneously, 1 and 2 steps. Perfect. Move. Next step, slow moves 1, fast moves by 2 steps. Perfect. If you carefully observe, this is standing at middle 1. Here's the middle 2. In this problem, you need to stand at middle 1. You will not go to middle 2, which means the fast pointer will be standing at the second last node. It won't go to the last node, or rather null, as it did in finding the middle of the node, because over there we were finding M2. So fast will end up going to the null. Okay, so we need to make sure that we stop when fast reaches the second last node, which basically means fast next should not be null. We keep on going till that time. The moment the next should not be null, we keep on moving till that time. The moment the next is pointing to null, we should stop. Otherwise, we keep moving. Perfect. So the first half is done, which is recognizing the second half and the first half. You know one thing? This is the node which is basically slows next. This is the head of the second half. This is the head of the second half. What is my next job? The next job is to make sure the links are reversed so that I can easily traverse. So what I will do is, I'll try to reverse this entire linked list, the second half linked list. I'll try to reverse it. We've already done reverse, right? So I'll call the reverse function and I'll pass slow next. So what will happen is, it will reverse the second half. It will reverse the second half and it will return a new head. It will return a new head by reversing. Once it reverses, how will it look like? It will be something like 1 will be here, 1 will be pointing to 2, 2 will be pointing to 3, 3 will be pointing to null, correct? Can you tell me one thing? 3 be pointing to 1? No, right? You never change the link. 3 still points to the previous 3 because that is how the original link list. I try to reverse it. We've already done reverse, right? So I'll call the reverse function and I'll pass slow next. So what will happen is it will reverse the second half. It will reverse the second half and it will return a new head. It will return a new head by reversing. Once it reverses, how will it look like? It will be something like 1 will be here. 1 will be pointing to 2. 2 will be pointing to 3. 3 will be pointing to null. Correct? Can you tell me one thing? Will the 3 be pointing to 1? No, right? You never change the link. 3 still points to the previous 3 because that is how the original link list look like. You only make sure that these links are changed. These links are changed. The 3 is still pointing to 3. It's still connected. Perfect. I've reversed it. What's my next job? My next job is maybe taking 2 pointers. So what I'll do is I still have slow here. I'll take 2 pointers. One is the first and the other one is the second. And the second will be pointing to the head. Second will be pointing to the new head. That's where second will be standing at. And let's try comparing. 1 matches. Let's move them. Second goes here and the first comes here. This matches. First goes here and the second goes here. This and this matches. The first will this time move here, but the second will move here, which is a null. The moment it reaches a null, you say stop, and you are able to compare everything. So it is correct. It is a palindrome. But before returning true, please make sure that you again reverse it. So what you'll do is you will say, okay, please reverse the new head again. So this time, again this will be reversed. So before returning true, make sure you bring back the links back to how the linked list was. So it's like 3, 2, 1 pointing to null. And this is still connected to 3 because you never changed the link. 3 to 2 and 2 to 1. So you reverse it back again. That's how it will look like. So you might be thinking, this is for an even length linked list. How does it work for something like an odd length linked list? In that case, what you'll do is you perform the same scenario, slow and the fast pointers. Do find out the first half and the second half. Slow moves by 1, the fast moves by 2. Perfect. Again move slow by 1. Slow moves by 1, the fast moves by 2. And this is where you stop. So basically you stop at the last node. You basically stop at the last node, which means fast of next is where you stop. Like fast of next should not be null. You will stop at the last. No, that's it. You stop at the last. Over here, you stop at the second last. So these are the couple of conditions you have to take care. What after this? You're standing here, right? Let's erase this. You basically again call the reverse. So this will get reversed. So you reverse slow of next. So you will have 1 pointing to 2, 2 pointing to null. And this 3 will be still connected to 2. Do the same thing again because this will be the new head. Do the same thing again. Take the first pointer pointing to head. Take the second pointer pointing to new head. And again do a comparison. Pretty simple. You just have to make sure that it stands at the middle. And for the even node, it stands at the middle one. That is the only thing that you have to take care. So let's write down the code. It will be in 3 parts. The first is finding out the middle. The second is reversing. The third is comparing. Got it? So the first part is finding the middle, right? Tortoise in the hare algorithm, so slow will be head. And the fast pointer will always be head. That's where we start off with. And we know the conditions. While fast next is not equal to null, we will keep running it. And fast of next, because we want to stand at middle M1. Next is not equal to null, we will keep running it. Perfect. And we will say slow goes by 1 step, which is slow of slow next. We will say fast will go by 2 steps, which is fast of next of next. Perfect. So what is the next step? Reversing the second half. So can I say node of star, that's in case of C++, in case of Java there will be no star. Reverse slow next, because slow will be the middle. And I'll say the next is the head of the second half. It will reverse you. So that was about the second step. What will be the third step? The third step is comparing. So let's take first pointing to head. Let's take second, which will be pointing to the new head. Do not touch new head. And let's keep moving them. We know the second will get exhausted. Second is the second half and it will reach null after a point. So we will say second is not equal to null. And over here, we will say if first data or first value is not equal to second's data or value, whatever it is, we will be returning a false. But before that, please make sure whatever reversal you have done, you re-reverse it, reverse new head again. So we'll come back to it, original configuration, and you can return false. You can return false. Perfect. If that's not the case, you will say, hey, first, can you move by 1 step? He'll be like, why not? And you'll say, second, can you move by 1 step? Second will be like, why not? And then the while loop ends. After that, if everything has been compared, then it means return true. But before returning true, what is the step? You re-reverse it. So basically you call the reverse and you say, hey, this thing, can you just get it back to the shape? This is very, very important, specifically for interviews. Specifically for interviews, this is very important because people don't want you to alter the given data. So if you've done something, make it back to the original configuration. That's very important. What is the time complexity if I have to analyze? This is step 1. Can I say bgo of n by 2 because it will go halfway to find out the middle. Perfect. I'm reversing the linked list. So I'm reversing a half section of the linked list. So that's a bgo of n by 2, right? I'm again traversing the first half and the second half together. But can I say, if I go back to the example, I'll end up traversing 1 node, 2 node, 3 node, which is basically half of the nodes in order to compare half of the nodes. So this while loop will be bgo of n by 2 again, right? And can I say I'm reversing again, so which is bgo of n by 2. So technically, it's like n by 2 plus n by 2, which is n by 2 plus n by 2, which is n. So the time complexity is overall bgo of 2n, right? And the space complexity overall is bgo of 1. Yes, we're using pointers, but that will not take a lot of memory, not like what stack was taking. So should be it. This is the optimal approach. So let's quickly get back into the code editor and check out the edge cases. If you look at the first line, very simple. If it is an empty linked list,
Okay, so checking if a linked list is a palindrome or not. इसमें मैं समझ तो गया कि कैसे करना है, बट अभी मेरे को लग रहा है कि मेरे को सो जाना चाहिए क्योंकि आई एम एग्जॉस्टेड. बट एटलीस्ट मैंने थर्ड प्रॉब्लम का समझ लिया कि कैसे क्या करना है. कि पहला स्टेप है कि आपको मिडिल तक पहुंचना है. ठीक है, लिंक लिस्ट के मिडिल तक पहुंचना है, सिंगल लिंक लिस्ट के मिडिल तक पहुंचना है. एंड अगर इवन नंबर्ड है तो फिर जो अपने को फर्स्ट, मतलब इवन नंबर्ड में 2 आएंगे ना मिडिल वाले, तो पहले मिडिल वाले तक ही पहुंचना है. द रीज़न बीइंग क्योंकि अगर 6 है तो हमको थर्ड नंबर वाले पे ही पहुंचना है ताकि हम उसको आधा आधा कर पाए, 3 इधर 3 उधर. ठीक है, तो ऐसा करना है. और वेट, लेट मी डू समथिंग. यार एक तो यहाँ ओके, आई फॉरगॉट कि उस वाले में मैंने इनपुट डाला ही नहीं था. तो एनीवेज मैं कह रहा था कि पहले आपको मिडिल तक पहुंचना है. ठीक है, एंड वो करेंगे हम फास्ट एंड स्लो पॉइंटर यूज़ करके, जो कि जिसको हम बोलते हैं टॉर्टॉइस हेयर मेथड या तो टर्टल रैबिट मेथड. फास्ट पॉइंटर 2 स्टेप से आगे बढ़ेगा, स्लो पॉइंटर 1 स्टेप से आगे बढ़ेगा. इसको कर करके हम पहुंच जाएंगे मिडिल में. वहाँ पे हमको क्या करना है, जो फर्स्ट मिडिल तक जो था, ठीक है, एक जैसे मानो 6 अगर लेंथ है, 6 नोट्स है, तो 1 2 3 ये जो पहला पार्ट है ना, इसको हमको क्या करना है, इसका जो थर्ड का जो नेक्स्ट है उसको पॉइंट करते रहना है अपने को नल की तरफ. एंड जो फोर्थ था, जो बेसिकली जो अभी जो सेकंड लिंक लिस्ट का जो पार्ट है, उसका जो हेड है वो फोर्थ एलिमेंट बनेगा जो ओरिजिनल का था, जो सेकंड मिडिल एलिमेंट है. ठीक है, अब उसको हमको करना है रिवर्स. उसको हम रिवर्स करेंगे, देन हम कंपेयर करेंगे 2 पॉइंटर्स लेके. कुछ भी ले सकते हैं, आई एंड जे ले सकते हैं, या तो कुछ भी ले सकते हैं, x1 x2 कुछ भी. तो जो 2 पार्ट्स हो चुके हैं, ठीक है, पहला ये पार्ट था, दूसरा ये पार्ट था, हमने इसको रिवर्स कर दिया. ठीक है, तो अब इसका पहला, इसका पहला, इसका दूसरा, इसका दूसरा, हैड 1 हैड 2 कंपेयर करेंगे, देन +1 करेंगे, देन +1 करेंगे, कंपेयर करेंगे. अगर अगर कंपेयर करते करते इसके कुछ तो मतलब अगर मिसमैच हुआ है, नॉट इक्वल्स टू आया अगर किसी वैल्यू का करस्पॉन्डिंग वैल्यू से नॉट इक्वल्स टू आ रहा है, तो फिर हमको फिर से रिवर्स करना है, फिर ओरिजिनल वाले उसमें लेके आ जाना है. एंड देन वी हैव टू रिटर्न फॉल्स कि नो दिस इज़ नॉट अ पैलिंड्रोम. एंड इफ़ सारे मैच कर जाते हैं, देन वी विल रिटर्न ट्रू बिकॉज इट इज़ अ पैलिंड्रोम. अगर सब मैच कर रहा है तो ठीक है. एंड देन उस रिटर्न ट्रू करेंगे. एंड रिटर्न ट्रू करने से पहले हम वापस रिवर्स कर देंगे सेकेंड पार्ट को, ताकि ओरिजिनल लिस्ट आ जाए वापस. तो मैं ये समझ तो गया हूँ, बट अभी मेरे को इसको कोड करना है, तो कोड मैं कल कर लूँगा. आज का समरी ऐसा रहा कि आज मैंने 3 प्रॉब्लम्स समझ लिए, 2 प्रॉब्लम्स कोड कर लिए. ठीक है. पहली प्रॉब्लम थी हाउ टू डिटेक्ट अ लूप इन अ लिंक्ड लिस्ट. सेकंड प्रॉब्लम थी कि सॉरी फर्स्ट प्रॉब्लम थी हाउ टू रोटेट अ लिंक्ड लिस्ट. एंड इसमें क्या चाहिए था, एक बार मैं इसका भी देख लेता हूँ ताकि रिकैप हो जाएगा क्या करना था इसमें. रोटेटिंग अ लिंक्ड लिस्ट, ठीक है, वी नीड लेंथ एंड वी नीड टेल. ठीक है, लेंथ को इनिशियलाइज करके 1 करेंगे, टेल को इनिशियलाइज करेंगे हेड. वाइल टेल का जो वाइल, हाँ ठीक, अच्छा बेसिकली जब तक टेल का नेक्स्ट इज नॉट इक्वल्स टू नल, हम एक लूप रन करेंगे जिसमें लेंथ का वैल्यू बढ़ाएंगे एंड देन टेल को अपन टेल डॉट नेक्स्ट पे लेके आते रहेंगे। ठीक है, वाइल लूप करके इंक्रीमेंट कर रहे हैं, ट्राइवर्स कर रहे हैं हम लिंक लिस्ट के थ्रू एंड देन इफ के, हाँ ठीक है, के अगर लेंथ से बड़ा है तो फिर उसको वहाँ पे हम ये इस चीज़ को हैंडल कर रहे हैं। इसका कोड प्रॉपर रहेगा कि इफ नॉट हैड और नॉट हैड डॉट नेक्स्ट देन रिटर्न हैड। बेसिकली अगर एम्प्टी लिस्ट है या तो अगर सिंगल नोड लिस्ट है तो हम रिटर्न वापस हैड ही कर देंगे, क्योंकि हमको रोटेट नहीं, कुछ फ़ायदा नहीं आएगा, रोटेट नहीं हो पाएंगे क्योंकि एम्प्टी या तो सिंगल नोड है तो क्या रोटेट होएगा। देन लेंथ एंड टेल को इक्वेट करेंगे वन एंड हेड के इक्वल्स टू, मतलब लेंथ को वन लेके इनिशियलाइज करेंगे एंड देन टेल को हम हेड लेके इनिशियलाइज करेंगे, मतलब जो फर्स्ट एलिमेंट है वहाँ पे हम टेल चालू करेंगे वहाँ से। एंड देन वाइल टेल डॉट नेक्स्ट टेल इज इक्वल्स टू टेल डॉट नेक्स्ट एंड देन लेंथ इज इक्वल्स टू लेंथ प्लस वन। हाँ ये तो मतलब ठीक है। उसके बाद हम क्या करेंगे, एक सर्कुलर, हम उसको एक सर्कुलर बनाएंगे। कैसे करेंगे, टेल डॉट नेक्स्ट इज इक्वल्स टू हैड करके, मतलब टेल का जो आखिरी है, टेल जहाँ का जो लास्ट एलिमेंट है उसको पॉइंट करवा देंगे फर्स्ट एलिमेंट की ओर, ताकि सर्कल बन रहा है। ठीक है, नाउ हम एक लूप रन करेंगे फॉर आई इन रेंज लेंथ माइनस के, देन टेल इज इक्वल्स टू टेल डॉट नेक्स्ट। इसका मतलब क्या है, फॉर आई इन रेंज लेंथ माइनस के इज द अमाउंट बाय विच वी नीड टू रोटेट द लिंक्ड लिस्ट, एंड जो लेंथ है, लेंथ में से के माइनस करेंगे, लेंथ माइनस के, जैसे 5 अगर लेंथ मानेंगे तो के अगर 2 माने तो 5 माइनस 2 इज इक्वल्स टू 3। ठीक है, तो 3 तक टेल इज इक्वल्स टू टेल डॉट नेक्स्ट करेंगे, 3 तक करेंगे, 3 पे आएगा तो 3 पे क्या आएगा, टेल डॉट नेक्स्ट 4 आ रहा होगा, तो 4 वहां से हमको काटना है। ठीक है, एंड देन हेड इज इक्वल्स टू टेल डॉट नेक्स्ट, अगर 3 तक आ गए, 3 पे टेल है ठीक है अभी तक, तो 3 डॉट नेक्स्ट मतलब 4th वाला जो है वो नया हेड बन जाएगा, एंड जो टेल डॉट नेक्स्ट है मतलब 3 के बाद जो 4 है, सॉरी टेल डॉट नेक्स्ट मतलब टेल का जो नेक्स्ट वाला है उसको हम नन की तरफ पॉइंट करा देंगे। ये कब होता है, लास्ट एलिमेंट में होता है। जो ये टेल किसकी बात कर रहे हैं, जो ये नई टेल बेसिकली जो थर्ड पे आके रुके हैं ना, टेल वाला पॉइंटर रुका है उसकी बात हो रही है। तो थर्ड के नेक्स्ट को हम हेड बना देंगे, मतलब फोर्थ हेड बन चुका है, और टेल का जो टेल डॉट नेक्स्ट मतलब थर्ड का नेक्स्ट इज इक्वल्स टू नल, मतलब थर्ड अब नया टेल बन चुका है, फोर्थ जो था अब वो नया हेड बन चुका है, तो फोर्थ के बाद फिफ्थ एंड देन 1 एंड देन 2 एंड देन 3, तो ये हम रोटेट कर चुके हैं बाय 2, क्योंकि के वॉज 2। ठीक है, ओके हाँ, सो दिस वॉज लाइक दिस प्रॉब्लम, एंड एंडिंग में रिटर्न करना है हेड। ठीक है, ओके। So this was the first problem, and the next was detecting a loop in a linked list, and इसके दो अप्रोचेस हैं, एक जहाँ पे हम एक हैश सेट यूज़ कर लेंगे जहाँ पे हम सारे नोड्स एंड उनके डेटा को स्टोर करते रहेंगे एंड अगर किसी पॉइंट पे एक रिपीट हो रहा है तो हम बोल देंगे, रिटर्न कर देंगे ट्रू कि यस दिस हैज़ अ लूप इन इट। एंड जो बेटर अप्रोच है वो है टॉर्टॉइज एंड हेयर वाली, मतलब वही फास्ट स्लो पॉइंटर, एंड हाँ मतलब फास्ट चलेगा स्लो चलेगा, एक पॉइंट पे आके जब अगर फास्ट एंड स्लो ओवरलैप करेगा तो ट्रू रिटर्न कर देना है। तो इसका कोड ऐसा रहेगा कि स्लो इज इक्वल्स टू फास्ट इज स्लो इक्वल्स टू फास्ट इक्वल्स टू हेड, इनिशियलाइज कर दिया। ठीक है, वाइल फास्ट एंड फास्ट डॉट नेक्स्ट, मतलब क्या है इसका, मतलब वाइल फास्ट इज नॉट नन एंड फास्ट डॉट नेक्स्ट इज नॉट नन, इसका यही मतलब है, नॉट नन, हाँ यही मतलब है इसका। मतलब क्या है कि फास्ट डॉट नेक्स्ट इज नॉट नन, लेट मी थिंक, हाँ मतलब जो फास्ट पॉइंटर है वो हमको एंडिंग तक नहीं लेके जाना है, लाइक टेल तक नहीं आ जाना चाहिए वो, ये मतलब वही कंडीशन है इसकी। तो पहले करेंगे स्लो इज इक्वल्स टू स्लो डॉट नेक्स्ट एंड देन करेंगे फास्ट इज इक्वल्स टू फास्ट डॉट नेक्स्ट, मतलब स्लो 1 से बढ़ रहा है आगे, फास्ट 2 से बढ़ रहा है आगे। एंड इफ स्लो इज इक्वल्स टू फास्ट, लाइक इफ स्लो डबल इक्वल्स टू फास्ट, मतलब दोनों के अगर डेटा वैल्यूज सेम आ जाएंगे तो फिर रिटर्न करना है ट्रू, otherwise we have to return false, and this was the approach। हाँ तो ये दूसरा प्रॉब्लम था, और तीसरा प्रॉब्लम था अपना पैलिंड्रोम वाला। एंड पैलिंड्रोम वाले का जल्दी से रिकैप करके अगर मैं बताऊं तो जो लिंक्ड लिस्ट है उसमें टॉर्टोइज हेयर मेथड फास्ट एंड स्लो पॉइंटर यूज करेंगे एंड मिडिल नोड्स तक पहुंच जाएंगे। अगर ऑड है तो एक मिडिल नोड रहेगा, तो फिर उसके बाद तो दिक्कत नहीं है। इवन में दिक्कत आएगी कि दो मिडिल नोड्स रहेंगे। एंड हम ये क्यों कर रहे हैं, क्योंकि हमको दो पार्ट्स में काटना है लिंक्ड लिस्ट को एंड दूसरे पार्ट को रिवर्स करना है एंड देन यहाँ 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 करते करते दोनों के टेल्स तक हमको कंपेयर करना है। एंड अगर कंपेयर करके सेम निकला मतलब यही है कि वो पैलिंड्रोम है। करेंगे कैसे, पहले लेंगे स्लो एंड फास्ट पॉइंटर यूज करेंगे, मिडिल वन एंड मिडिल टू दो आएंगे अगर इवन रहेगा तो मिडिल वन तक पहुंचना है। ठीक है, यहाँ तक पहुंच लिए। अगर छः हैं तो यहाँ तक तीन आ गए, यहाँ तीन बच रहे हैं। ठीक है, तो ये जो है टेल या मतलब कुछ भी बोल सकते हैं, जो भी पॉइंटर का नाम है टेल अगर मानेंगे, या क्या माना था इसे, स्लो, सॉरी स्लो। स्लो यहाँ पे है तो फास्ट एंड तक आ जाएगा। ठीक है, तो स्लो डॉट नेक्स्ट जो ये है, ठीक है, स्लो डॉट नेक्स्ट जो मिडिल M2 सेकेंड मिडिल एलिमेंट है वो हमारा इस सेकेंड लिंक्ड लिस्ट जो बाइफर्केशन कर दिया है इसका नया हेड है। ठीक है, तो जो स्लो डॉट नेक्स्ट है वो इसका नया हेड बन चुका है। ठीक है, तो अब हमको क्या करना है, इस वाले को रिवर्स करना है, तो इस पर हम रिवर्स फंक्शन लगा देंगे। ये रिवर्स हो चुका है। ठीक है, अब एंड अब हमको कंपेयर करना है यहाँ यहाँ इन दोनों के हेड को लेके टेल तक पहुंच जाना है, कंपेयर करते रहना है। अगर बीच में भी कंपेयर करते समय कुछ डेटा वैल्यूज सेम नहीं आई, ये लाइक अगर मैच नहीं हो रहा है, अगर यहाँ पे हेड इसका वन है यहाँ पे हेड टू है, तो वही के वही हम इसको रिटर्न कर देंगे फॉल्स। ठीक है, एंड अगर लाइक लूप रन कर देंगे, या तो ऐसा फॉल्स हो जाएगा या तो फिर वो हेड से लेके टेल तक इसके एंड इसके कंपेयर करता रहेगा। एंड अगर उस केस में पॉजिटिव उस केस में अगर सारे कंडीशंस फुलफिल रहे तो रिटर्न कर देंगे ट्रू। एंड मोस्ट इम्पॉर्टेंटली ट्रू रिटर्न करने से पहले हम जो ये सेकंड पार्ट है इसको वापस ओरिजिनल वाला ला देंगे। ठीक है, एंड देन यहाँ के जो यहाँ पे दोनों कट करे थे, मतलब जो इन दोनों की लिंक कट करी थी उनको वापस लगा देंगे। मतलब इसका जो पॉइंटर नन की तरफ पॉइंट हो रहा होगा उसको हटा के अब पॉइंटर इसके डॉट नेक्स्ट पे लगा देंगे, ऐसा कर देंगे। सो या दैट वाज इट फॉर टुडे। एंड करीब करीब 4 घंटे का स्ट्रीम खींच लिया मैंने, जिनमें से 1 घंटा तो मैच ऐसा था भी नहीं यहाँ पे, बट स्टिल 3 घंटा इज अ गुड, लाइक इज अ गुड अमाउंट ऑफ टाइम। और क्या बताता हूँ, और वीडियोस कमाया हुई हाँ ये रहा। इसके पहले 4 दिन पहले, मतलब अगर 24 घंटे के बाद का अगर ये आज नया दिन कैलकुलेट ना कंसीडर ना करूँ तो इसके पहले मैंने 3 दिन पहले स्ट्रीम करी थी एंड आज है मेरी फिर से, मतलब जो मैं कंटिन्यू कर दिया। सो या दैट्स इट फॉर टुडे एंड अभी आई एम गोना गो टू स्लीप। टाइम हो चुका है, 2:30 बज रहे हैं रात के। एंड आई एम हैप्पी कि मतलब कि मैंने स्ट्रीम स्टार्ट कर दी, वरना फिर आज भी मैं अगर एहतलाली कर देता तो फिर नहीं हो पाता काम। ओके, सो आई एम गोना गो नाउ एंड कल मैं, और शायद से मैं कल 2 स्ट्रीम्स कर दूँ, 4+4 8 आवर्स, 8 आवर्स शायद से कर दूँ। या बाय दोस्तों, आई एम गोना गो नाउ।